a marshmallow?
Correct.
Correct. So what we're going to start by doing is making our own little periodic table. Our periodic table consists of 3 elements. Those being marshmallows, graham crackers, and chocolate bars. Okay, since there's only 3 elements on our periodic table, I'm just going to give them atomic numbers 1, 2, and 3. Okay. Here's a graham cracker. And here's a chocolate bar. Really? Yes. Now, each of these we're going to assume is 1 mole. This is 1 mole of marshmallow particles. This is 1 mole of graham cracker particles. This is 1 mole of chocolate particles. Okay? And what you did is you weighed these things. You figured out what does 1 mole of these things weigh. That's what we put down here. Marshmallows. What do they weigh?
7.7.
7.7?
7.29.
Well, an average would be better, right? Okay. I don't really care what the actual number is, but 7.7 is kind of high. Most people I was seeing was something about 7.1, 7.2. All right. So I'm going to put 7.15 on there. Graham cracker, what does that weigh?
3.82.
3.79.
Okay, getting 3.7 is 3.8, so I'm going to say 3.75. And chocolate bar.
3.2.
Okay, people getting 3.2s, I'll put 3.22 just for fun. Okay? Now again, on the periodic table, actually I think I'm going to change the color of these. So what I want to do is to color code my calculations so you can tell when I use a number where it came from. Okay? These numbers on the bottom, remember on our periodic table, we called them what? Atomic masses, right? The mass of an atom. In what unit? AMUs, which stands for?
Atomic mass
units. But do we measure things in the lab in atomic mass units?
No.
No, we measure them in grams. So we're going to treat these numbers on the bottom of the periodic table, not the number of atomic mass units per marshmallow molecule, but the number of grams in a mole of marshmallow molecules, right? These are the molar masses. That's the mass in grams per 1 mole. All right. Okay. So now the question we're really trying to, well, I guess we're trying to do a couple things. First thing we're trying to do is, what is the reaction between marshmallows, chocolate bars, and graham crackers to make the product we're trying to make? We're trying to make a s'more, right? So we need a balanced equation to figure this out. But we also need to know in what natural form are these things found. When I go to the grocery store and I buy a bag of chocolate bars, am I just buying a bag of these little guys? No. What am I buying? Well, it depends. You can actually buy different types. I was hoping she would have bought the nice big ones. Okay, those have 12 of these little bars attached to them. But we didn't get those. We got the little snack size. That's okay. But it's important to understand that the snack size, if I open this up, it's got 4 of these connected to each other, right? So some people that were coming up and were confused about that, I said, well, it's like oxygen. Oxygen on the periodic table, it weighs 15.999, right? Grams per mole. But when we do a chemical reaction, we're using oxygen from the air. It's O2. It's not found as individual oxygen atoms. It's found as oxygen molecules. So in the same way, chocolate bars are actually found as little molecules of 4 individual atoms of chocolate, I guess, right? Graham crackers. this is what we weighed, but that's not what we're going to use to make our s'more. We're going to use one of these, right? One for the bottom, one for the top. And this is like 2 of these little grams stuck together. That's where I said GC2. Marshmallows, those are found as individual little things, right? So there's no subscript after the marshmallow. Okay, now we got to think about what is it that we're trying to make. Well, to make a s'more, we're going to take a graham cracker base. We're going to add to it, actually, the recipe I said, we're going to use 2 of these little bars, right, to totally cover up that base. Yummy, yummy. It's going to be chocolate spilling everywhere. It's going to be delicious, right? Then we're going to put a toasted marshmallow on it. Then we're going to put another graham cracker on the top. Boom. Does that look like a s'more?
No.
Don't eat the wrapper, but yeah. It doesn't look like a s'more to you?
That's not how you put the marshmallow.
Where do you put the marshmallow?
Put it horizontally.
Yeah?
Hey.
Oh, okay. So now we've got a s'more. Okay, maybe that was the source of confusion the whole time, right?
So now you guys better take a note and say
Yes,
s'mores
this
are
is the
horizontal.
way you make a s'more. Okay. Okay. So now we got to figure out what's in this thing. What atoms are there? There's one marshmallow, right? So an MM. There's graham crackers in there, but how many of these little individual graham crackers make up the s'more?
4.
4. Graham cracker. 4. What about chocolate bars?
8.
8 little individual chocolate bars in 2 little chunks, right?
Yeah.
But really we have 8 total little chocolate bars, right? So now we understand what the skeleton equation is, we got to balance it. Balancing was pretty easy, right?
Yeah.
We've got a 4 here, a 2 here, we need a 2. We've got an 8 here, a 4 here,
Need another 2.
need another 2. Okay? So there's our balanced equation. What does our balanced equation tell us?
What combination of all these things you need to make a proper s'more?
What combination of these things we need to make a proper score? On what units? What do you mean, how many of these things?
So like it's in atomic mass units, so we have to change it to moles.
So this tells us how many atomic mass units of marshmallow. We need 1 AMU of marshmallow plus 2 AMUs of graham cracker plus 2. We need 1 gram of this plus 2 grams of this.
1 mole.
I think I meant it like 1 marshmallow, which is 7.15 AMUs.
Okay,
plus 2.
so what this really tells us is the number of things that we need, right? The number of things could be the number of particles. I suppose I could make some sort of nano s'more, right? I could take 1 little molecule of marshmallow. I could take 2 little molecules of graham crackers and 2 little molecules of chocolate bars and combine them to make 1 little molecule, 1 little nano s'more, right? Maybe that's what you guys deserve. We give you guys nano s'mores. Okay? Nobody wants a nano s'more. You're not even going to taste it, right? You're too small. You can't see an individual molecule. You think you can, oh, super taste bud. This guy. Okay.
Taste the air.
We want to make it with a whole bunch of these molecules, right? So we're going to scale this reaction up. But no matter how much I scale it up, these ratios have to be the same. Okay? So if I want to use a dozen molecules of marshmallow, how many dozens of molecules of graham crackers am I going to need? 2 dozen, right? I would need 2 dozen molecules of chocolate bar, right? What if I had 1,000 marshmallow particles? I would need 2,000 graham cracker particles and 2,000 chocolate bar particles, right? I'm going to scale this all the way up to a huge number.
Oh no.
6.022 times 10 to the 23rd particles. We call that
Mole.
a mole.
1 mole.
If I have 1 mole of marshmallow particles, then I need 2 moles of graham cracker particles. And I need 2 moles of chocolate bar particles. Okay? So we're going to treat this balanced equation. It's most convenient in chemistry to treat it as a ratio of the number of moles of things that we need. Okay? So this is the recipe, essentially. On a mole basis. Tells us how many moles of each thing we need and how many moles of things we produce. Okay? Now the question that I asked you in the lab was, based on the amounts that we have in the packages, how many s'mores can we make?
So you have to.
So the first thing we had to do is we had to know, well, how much stuff do we have? It would probably have been very easy for me to just say, take out the packages, figure out how many are in there, count them all up, right? You could have just added up, oh, there's, 50 graham crackers in there, so I know, well, if there's 50 graham crackers, and each recipe needs 2, how many times can I do the recipe?
25.
25, right? That would have been easy. But I didn't make it easy on you. No, I'm a jerk. What did I do? I said, well, wait, let's figure out what the package weighs. This package has 726 grams of graham crackers in it. Now, we can assume the graham crackers are in there as little squares of graham crackers. Okay, it doesn't really matter. But we have 726 total grams. The marshmallows, we have 283 grams. And the chocolate, assuming nobody ate any of these. Actually, I ate one. 293. Okay? There's a problem. If we know the mass of these things, we can't really use it yet. Because it's not in the same units that our equation is in. Our equation is in moles. What we have is a number of grams. Okay? The question we're really going to try to ask here is, given these amount of ingredients, what mass of s'mores can we make? How many s'mores can we make? Okay? So the first thing we have to do is we have to convert these to moles. Because I can't use the balanced equation unless these are in moles. So that's the first thing I ask you to do. Well, these are all going to be proportions.
Oh, yes.
They're all going to be ratios, right? This tells me that every 7.15 grams of marshmallows is 1 mole of marshmallows. I'm going to write that in red, so you know it's coming from the molar masses. 7.15 grams of marshmallows is proportional to 1 mole of marshmallows. Right?
Yeah.
Now, what do we know about the marshmallows in our sample? We know there's 283 grams. Right? We don't know how many moles that is, but we know it's proportional. So if we set up an X here, we can solve this proportion, figure out how many moles of marshmallows there are. Everybody, with your calculator, solve it right now, using these numbers. I want everybody to do it. Because if your algebra skills are not really super tight, this is not an easy calculation. Got an answer? Shh. Everybody's going to say it at once. The answer. Ready? X equals?
39.58041958.
39 point what?
39.58041958.
What are the units?
Grams.
No,
Moles. Because look, if moles was down here on the right side, this is moles down here on the left side. This is moles of marshmallows. way too many people were coming up to me with pages that did not have units on them. If you're not writing your units, then I don't know whether you did it right or wrong. Okay? Now, somebody asked me, how did I actually solve this? There's two ways. Cross multiplication is one way. I don't like cross multiplication. No, because it's a trick. Tricks are for kids.
So you can't see the shapes anymore?
We get it.
They're
Yeah.
round.
Tricks are also used by magicians who are not kids.
We're now
Yes. Tricks are used by magicians who do not reveal how it is done. Cross multiplying does not tell you how the mathematics works out.
Okay.
You just
Okay?
follow us.
So what I'm going to do is I'm going to take the inverse of both sides, right? Algebraically, I can do whatever I want to an equation as long as I do the same thing to both sides, right? Okay. So what do I mean by taking the inverse?
So like
Reciprocal.
Take the reciprocal, raise it to the -1, which for a fraction
multiply.
has the effect of flipping the fraction, right? The denominator becomes the numerator becomes the denominator. So it's actually easier to solve this if I have x over 283 equals 1 over 7.15.
Why didn't you just
So
write
like
it like
always
that?
try to get the x on top. It's fine.
Yeah, you can write it. If you want to, it's probably easiest to always put your unknown on top. Say x is what I'm trying to solve, okay, and then say, well, whatever it is I'm trying to find, if it's moles, then I got to put moles on the top on the other side, okay? It doesn't really matter. All right, now how do I solve this? Well, x is being divided by 283, so to undo that, I have to multiply each side by 283. Okay, now I saw a lot of people coming up and thinking they were going to multiply the 7.15 by 283. No. I'm multiplying this fraction, 1 over 7.5 times 283. Okay, so in your calculator, put it in parentheses. Open parentheses. 1 divided by 7.15. Close parentheses. Then multiply that by 283. You should get 39.58. Does that answer make sense?
Yeah, we're basically divided to
But does the answer make
Yeah.
sense? Why, Kyle? What are we trying to find?
Because it's one, it's the same proportion
Oh,
as one
well,
over
yeah,
seven.
yeah, it makes sense.
Why?
There's 7.15.
Because 39.58 equals to 1 whole and 7.1.
Because it looks like there's about 40 marshmallows.
Looks like there's about 40 marshmallows in here. This is the number of marshmallows,
Hey.
I got you.
right? Now if I look on the back, it says serving size 4 pieces. Servings per container, about 9. What's 9 times 4? 36.
17.
Pretty close to what we got. We just calculated what it has on the back already for us. Somebody came up in there, 1, 2, 3. No! Just solve it like this. Set up a proportion.
Are we wrong or are they wrong?
Well, it says about 9.
We're right.
So it could be more.
Could be.
It could be like 9.5.
Could be 9.5.
It depends on
Could be
like
10. I don't know.
10 times 4 is
Good question. I don't know. Maybe some marshmallows are a little bit bigger than
Well,
others,
we
right?
have to count them
Well,
now.
some say like
Okay.
how many are in the bag.
Okay. So now that we know how many moles of marshmallows, what we really want to know is how many s'mores can we make?
well, don't you have to do the same to calculate and grab?
Yes, we're going to do that for the other ones in a minute. But let's just focus on the marshmallows. If we have 39.58 moles of marshmallows, how many more moles of s'mores can we make? Well, to figure it out, we need to multiply by a ratio, a proportion.
Don't know.
The proportion we're going to multiply by, Mia?
So if one's more has 1 marshmallow, so it's 1 to 1.
Yeah, it's the recipe. Now that we know how many actual marshmallows we have, we can use this recipe that says 1 marshmallow gives us 1 s'more, right? Of course, we're scaling it up to moles, right? But that's okay. 1 mole of s'mores per 1 mole of marshmallows. Actually, I put SM here. I'm going to put the formula for a s'more. GC4, CB8. That's a s'more. right? So we do this calculation, what do we get? Times 1 over 1, 39.58 s'mores. Right?
Yeah.
Now I also asked you, maybe it's, I don't know, maybe we're shipping these things, right? We're FedExing them to our friends in
Portland, Oregon.
Portland, Oregon, where they don't have s'mores. Okay? And we need to know for FedEx or whoever going to send it, we need to know how much this batch of s'mores we made weighs. Because they're going to charge us by the gram. Okay? So how do we figure out how much this amount of s'mores weighs?
So you need to find how many grams one s'more weighs.
We need to figure out what one s'more weighs in grams. I asked you to do that. Yeah, at the beginning of the lab. Well, what's in a s'more?
One marshmallow,
One marshmallow, so 7.15.
4 graham crackers,
4 graham crackers, so plus 3.75 times 4,
and 8 chocolate bars.
and 8 times the 3.22 that each chocolate bar weighs. All right. So for these numbers, what do we get? Add them up.
Plus 3.22 times 8. 47.91.
Somebody confirm that?
I'm always right.
I got 47.8. Oh, yeah. But for the lab, I got
You good?
47.
47.91 using these numbers.
Yeah, exactly.
Okay.
Mm.
So this thing weighs 47.91 grams per mole. Okay? So now we could set up another proportion. We could say,
Multiply 47.
how many grams of s'mores is there in 39.58 moles of them? Well, that ratio, whatever it is, has to equal the ratio we just calculated from the molar masses. We know that there's 47.91 grams of s'mores
And 1 mole.
1 mole.
for every 1 mole.
Okay.
Do it!
I think you can like shorten it to like SM because I think like writing that out.
I know. A lot of writing, but you didn't have to write any of it on the lab. All the units and stuff were already on the papers.
1,896.27 grams.
1,800.
96.27 grams.
What? Oh.
Somebody not get that?
Wait, don't you round it to 28?
Well, really, we only had 3 digits in the mass of marshmallows that we started with, right? So really, I can't even say that this is a 6, for sure. I'm going to say we're probably going to get about 1,900 grams, right? It's going to depend because every marshmallow is going to weigh a little bit different, right? Things like that, okay? But is this the number other people are getting in their calculator? Okay. So we can make about 1,900 grams of s'mores. But there's a problem.
This equals more than how many we have.
This is just for marshmallow.
Add up the total mass of stuff we have.
It's 1302. I just did it because I saw it. I saw it, I was like, dude.
There's only 1,300 grams of stuff here. How are we going to make 1,900 grams of s'mores with 1,300 grams of stuff?
You don't.
You cannot. So what's wrong? Did we do something wrong with our calculation?
No.
You didn't.
Because what we calculated is like the perfect equation for like the balance of like 1 marshmallow, 4 graham crackers, and 8 chocolate bars. But not every chocolate bar, not every marshmallow weighs exactly the same.
Yes, but there's something else going on. Okay?
Because
There's a reason this number will never be correct.
you're gonna run out of stuff. You're gonna run out of stuff.
We might run out of one of the other ingredients before we can make this number of s'mores, right?
Just because you have like about 40 marshmallows doesn't mean you have like.
Just because I have 40 marshmallows doesn't mean I have enough of everything else to make 40 s'mores, right? something else is going to limit how many s'mores we can actually make.
Are we gonna do that?
Thank you. Okay, so,
So you have all
that
these
was-
equations for the next.
so yes, we actually have to do every single one of these calculations. Again, we have to figure out, based on this number of graham crackers, what mass of s'mores can we make? Based on this grams of chocolate bars, what mass of s'mores can we make? That's what you're going to do right now. This side of the class is going to start with the graham crackers and calculate what mass of s'mores we can produce. You guys are going to start with the chocolate bars, so you're going to calculate what mass of s'mores we can produce.
Oh,
Bars.
because of 5 times 2.
What, in moles or grams?
In grams. I want to know the number of grams.
Well, we have to make sure it's 2 graham crackers, not we're just 1.
Chocolate bars?
Got it.
48.4 grams? That's less than even the grams of graham crackers that we started with.
193.4.
Oh, I want to know how many grams of s'mores we can make. I asked you guys not to take out a notebook, so I don't know where you're setting up these calculations, but you could set it up right on the lab where I asked you to do it, right? I gave you all kinds of space here for you to actually show me your calculations. You should be showing at least as much as I put here for the marshmallows, right? Because if you don't practice setting this up correctly, you're not going to really learn how to do it, and you're going to make mistakes when it comes time to do something more difficult, which is what I'm going to do next.
Oh, I got it.
I chose to do s'mores because everybody knows what a s'more is. That's a bad assumption. Have you had a s'more before, Joshua? Yeah, okay. So, everybody that's not from Mongolia knows what a s'more is.
Oh, what about people from Zimbabwe?
Okay, they probably don't know what a s'more is either. Okay, so I'm making a very,
It probably costs
what do we call that? A broad assumption? Yeah, it's sort of a,
Wait, I didn't say.
not racist, it's
What's you guys talking about?
cultural barrier. I was gonna say Eurocentric, that's the term I'm thinking of, but it's not Europe.
So,
It's Americentric, right? I'm assuming everybody grew up in America, in the Midwest, and everybody made s'mores, right?
That's incorrect.
Okay. But it is something that you can actually touch and make yourself, so trying to use something tangible before we do things that are less tangible, okay? So, people that did graham crackers. What mass of graham crackers are we going to make?
2,320.8.
Huh?
2,330.
2,333?
I don't get that.
What'd you get?
1,915.672.
1,915. What'd you get?
I'm not finished yet.
Not finished yet. Logan?
I'm not finished yet.
What did we get?
Wait, what is that 47?
First, we got to figure out how many moles of graham crackers.
What?
So, X moles of graham crackers
I didn't
in
get
726
so-
grams of graham crackers
Did you get 4,000 something?
is proportional to what?
I don't know if I even said it. From
1 mole of graham crackers.
Not-
Now we got to be careful. This is GC2s now, right? So we're not just going to use this because this is the molar mass of just one single GC. So So it's really 3.75 times 2, right? That's why I had you guys find the molar masses of the molecules on the first page.
Isn't it times 4 because you need 4?
No, we're not doing that yet.
7.5.
7.5. So actual graham cracker weighs 7.50 grams. Right? So how many of these graham crackers do we actually have? According to this calculation.
1.
No. It takes only 7.5 grams for 1 graham cracker. We have 726 grams.
Oh.
96? That sounds more reasonable. Almost 100. We have almost 100 times the mass we need for 1 graham cracker. So we, yeah, there's about 96 graham crackers in here. 96 point what? Now, if I look in the package, I wonder what it's going to say. Serving size, 8 crackers. 1 serving is 2 full cracker sheets. Servings per container, about 23. 23 times 8.
184.
Oh, that's way more. That's
184.
184, but that's for the big sheets. That's for one of these,
So divide
which actually has 2 of our crackers in it. So divide that by 2.
92.
92.
92! Woo! All right.
We'll get too
Too excited, right? Now that we know how many moles of graham crackers, we got to convert that to moles of s'mores. Now, actually, the way I set this up, I did this 2 different ways. So I'm going to set this up as a proportion. I'm going to say, okay, I'll use Y. How many moles of s'mores can we make? Those are GC4, CB8. With our 96.8 moles of graham crackers. What is the ratio between the moles we're going to make and the graham crackers we have? Well, that ratio is already defined by our balanced equation, right?
Wait, you're talking really fast, you know.
You don't need to write this down. You're going to write it down tonight. Stop writing.
What if
Just watch.
official studies in the way?
Smack it. How many moles of s'mores can we make with the moles of graham crackers we have? Well, the only way to know that is to look at the recipe. The recipe is the equation. The equation tells us what? How many moles of s'mores?
1 s'more, 2 grams EC2.
1 mole of s'mores per 2 moles of graham crackers. Okay, so now we have a proportion, right? Now mathematically, when I solve this, I'm going to multiply both sides by 96.8, so I'm going to get 96.8 times 1 over 2, which is actually the exact same math as what I did right here, okay? So you could do this 2 different ways, and I had on my answer key for the moles and grams and particles worksheet that we did before this, 2 different ways of solving it. One is to set up the proportion, the other one is to start with what you're given and multiply by the ratio that you know. I could have solved this by saying, well, I know I have 283 grams of marshmallows. Let me multiply by the proportion of grams and marshmallows. The proportion comes from the molar mass. But now I got to put the 7.15 on the bottom here because that's the number of grams. And I want grams and grams to cancel in my proportion. Then I'll put 1 mole of marshmallows on top because that's what I want my answer to be. If I solve this, I'm going to get the exact same answer. I'm going to get 39.58. Just 2 different ways of showing the exact same thing. These are exactly equivalent to each other. Okay? It just looks a little different. So whatever way looks better to you, is easier to understand, do that. Okay, how many moles of s'mores are we going to make with our graham crackers?
48.4.
48.4? Uh-oh. What's the problem with that?
You have more graham crackers than marshmallows.
Well, we have enough graham crackers to make more moles of s'mores than we could with the marshmallows. So are we going to use up this whole box?
No.
No. There's going to be a bunch of extra graham crackers, right? There's going to be excess graham crackers when we're done. Well,
Only like 9, I think.
that's true. Maybe not a ton extra, but that's assuming that the marshmallows is going to run out. We already know the marshmallows isn't going to run out because we can make more mass with the marshmallows than we have total massive stuff in there. So actually, we know now that the chocolate bars are going to run out. Okay? Well, let's finish this up. Last thing, we want to say how many grams of s'mores can we make in our 48.4 moles of s'mores?
4,687.
Well, that proportion is defined by our molar mass again, right? It takes 47.91 grams of s'mores. Yes, I am regretting not just using SN. What do we get? Logan? 2276?
One.
She got 233.
231.
231?
Yeah.
2,318.
Yeah.
So we'll say 2,320 grams here. Close enough, right? Okay? But are we going to make that?
Nope.
No way! Again, that's more than the total mass of stuff that we have.
So we subtract the less than
Subtract what?
so that we have more or less, and then we have to find what's left over.
Well, yes, we're going to do some leftover calculations in a second here, but I want to finish up with the chocolate bars. Chocolate bar people! 90.99.
I don't know.
11.37.
$37.
That's the mass of s'mores? That's less than the mass of chocolate bars we're making.
That's
The moles.
the moles.
What'd you get, Tom? 530.8. That makes more sense, right? Because that's more than the mass of chocolate, but less than the total mass of stuff we have. Anybody else get 530? All right, we better do this one to make sure. So, X moles of chocolate bars in 293 grams of chocolate bars is proportional to, now we got to be careful, 1 mole of CB4 weighs what?
3.22.
No,
I mean,
No.
oh, I did it wrong.
3.22 times 4. What is it?
3.2.
12.88?
Yeah.
Yes. If there's a subscript, we have to factor that subscript in when we use a molar mass, right? Just like if we're trying to do oxygen, which I'll do in a minute, we have to factor in that it's O2. All right, so what do we got for chocolate bars?
Oh, I still got it wrong.
Oh, 22.748.
Yeah.
What do you suppose I'm going to see when I look at the package of chocolate bars? Serving size, 3 pieces. Servings per container, 8.
24.
8 times 3 is 24. Real close to 25. Not right now. Maniacs out there might distract you. Quest. As soon as the second round, quest to fill the water. Okay, now we want to know how many s'mores we can make with this. Well, Y moles of s'mores.
Just write s'mores. Jesus, full.
Per 22.74 moles of chocolate bars, that proportion is fixed by the recipe. The recipe says what?
One
mole.
per four.
1 mole of s'mores? No!
Per 8.
No!
Two.
2!
What?
2!
Oh.
2 chocolate bars. Okay? This is where it gets confusing because sometimes people like to mix the steps, right? We already used the 4. We used it here to figure out the molar mass of a chocolate bar. So we don't want to use that 4 again. We're like double using that 4. Now we need to use the other number that's related to chocolate bars, which is the 2. That's the number of chocolate bar molecules required to make a s'more. Okay? So you can see the steps that I'm doing here. When I'm going from moles to moles, I need to use the equation. When I'm going from grams to moles, I need to use the molar mass. That comes from the periodic table. And factoring in what a molecule of these things has in it. Mia! Okay. You already did the last step. I mean, the last step's going to look the same as we did here, right?
Yeah.
So we're in s'mores. Now we're just going to grams. So what'd you get, Mia?
11.37422236.
That's less than the mass of chocolate we had. Oh, for this? 11. Okay, that makes sense. Sorry. The answer to this, yes. I asked if you had the answer to the grams of s'mores. Yes, we're making about 11 s'mores. And Tali, 11 s'mores at 47.91 grams each. That makes sense. It's about 500, right?
Yeah,
That's what, 533, is that what you got?
530.86.
Oh, 530.8. So I'll call it 531.
So that's the amount of s'mores you can
That's as many s'mores as we'll possibly be able to make, right? Because the chocolate bars are going to limit us to that many grams of s'mores. If we're doing an assembly line and we're making them and we're putting the s'mores on a balance, right? A FedEx, it's in our FedEx box and it's adding up and saying, okay, we're getting this many grams of s'mores, this many grams of s'mores, we're making them. As soon as we get to 531 grams of s'mores, what's going to happen?
We're gonna run out of chocolate.
The person putting the chocolate out on there is going to say, hey, I'm out. We're out of chocolate bars. Shut it down. S'more factory is out of business. Right? Person's going to say, oh, I got lots of marshmallows. Too bad. You think those people in Portland want chocolateless s'mores?
Yeah.
No. It's disgusting.
Whoa.
Question.
Mass.
This is the mass, yes.
The mass of the s'mores we could possibly make.
Yes, if we wanted to do it in moles,
It would just be divided by.
well, we could, yeah, just divide each of these by 47.91 to go back and figure out the number of, okay? But if we want to just show here, let's see, here we made about 39.58 moles. Here we made about 48.4 moles. And here we made 11 point, what was it, Mia? I'm sorry.
11.23742236.
What do you mean, hold on?
11.37422236.
This is another issue that I have with you guys. You do a calculation on your calculator, and when you're done with that calculation, what do?
Clear, right?
Why? Why clear it? Then when I come up and ask you what you did, you got nothing on your calculator to show me. If you make a mistake, bring your calculator up and I will tell you whether you had a problem with setting up your calculation in the calculator or whether it was a fundamental issue with how we set up these proportions. Okay? Never hit clear. That's going to go up there where that's never too late to quit. Just going to say never clear your calculator.
Never too late to clear.
It's always too late to clear your calculator. It's never a good time to clear your calculator. Okay? So, again, a couple of things we can say now about these calculations. We could say that chocolate is our limiting ingredient. Why? No! We actually have less mass of marshmallows than we have of chocolate.
The chocolate actually runs out here. Like the actual bar of chocolate.
You use CB8.
So we need more chocolate bars.
So why don't we
Make
just
it
use
smaller.
one
The
chocolate
reason
bar?
it's our limiting ingredient is because it limits us to the smallest amount of s'mores produced.
So,
That's what I think is the easiest definition of a limiting ingredient. The one that limits how much we can make. Chocolate bars is limiting us to 531 grams of s'mores. Marshmallows is not. We can make 1,900 grams with the marshmallows we have. But we're going to be limited to 531 grams because of the chocolate, okay? So you can't say it's because we have less of it. That's not correct. We have less mass of marshmallows than we do of chocolate, right? It's because it limits us to the smallest mass of stuff produced.
So if we would only use one chocolate bar, we'd be able to make more s'mores?
Yes. If the recipe was different, it might not be the limiting ingredient, but this is the recipe we were given. Okay? Now, another question that we can ask, well, if this is the limiting ingredient, the one that runs out, what are we going to call these?
Non-limiting.
Non-limiting. There's another word that I used.
Surplus.
Surplus. That would be a fantastic word. Surplus ingredients. Chemists don't use surplus, though. I'm sorry. It is a fantastic word. Chemists use excess.
Oh, that's lame.
yeah, sounds
Alright.
like honey cooler.
They are present in excess. We have extra of them. Okay, and one question we might want to ask is, how much extra? When the s'more factory shuts down, how many marshmallows are going to be left in that bag?
Let's calculate it.
Let's calculate it. How?
Well, if we know how many grams it limits us, then we can figure out how many of each things we'll use.
There's actually a whole bunch of ways to do this.
No.
If we know what mass of s'mores we're going to make,
We know how many things.
we could figure out what mass of marshmallows is required to make that. Right? Or, since we know how many grams of chocolate we're going to use, we can start with this number, and we can figure out how many grams of marshmallows we'll use. Either way, what we have to do is we have to start with something that we know about the limiting ingredient, and we have to convert that and say how much of our excess ingredient will that be proportional to. So I'm going to try it a bunch of different ways. I'm going to say, okay, well, we have 293 grams of chocolate bars. Well, the first thing I got to do is I got to get us to moles, right? So, how many moles of chocolate bars are there in 293 grams? We already did that. Where was it? 22.74. So why redo this? We already got the numbers. If we have 22.74 moles of chocolate bars, how many moles of marshmallows are we going to use? Now in this calculation, I went from chocolate bars to s'mores, but now I'm going from chocolate bars to marshmallows. Is it any different?
One chocolate, one marshmallow.
Still going to use the recipe. One marshmallow is going to be used for every two chocolate bars that we put in. So what's my answer here?
11.7.
What does this number tell us?
Okay, didn't we already know that though? We knew
I
how.
thought we had 39.58 moles of marshmallows. How are we getting 11.37 moles of
We
marshmallows?
already knew the amount of
That's
chocolate
the
bars that we can only
Because
make
that's
eleven
the
point
leftovers.
37 s'mores.
Because the ratio controls.
Oh, if you use up 2 moles of, or like 22.74 chocolate bars, then you'll have 11. Oh wait, that's how much that goes into one more, right? Or like, no, 1 to 2 is like
Okay.
1 to 2 ratio is like splitting that.
This is the hard part. Thinking about what are these calculations telling us? Marlon, give it a shot.
So, starting here with 293 grams of chocolate bars, which make 11.37 moles of marshmallows.
No.
I'm looking at the calculation in this middle one right here.
This is moles of s'mores.
Yeah, moles of s'mores, okay. So we already knew for 11.37 moles of s'mores, that was for 1 marshmallow. So we already knew we had 11.37 moles of marshmallows.
So what she's saying is we could have done this and said,
We didn't really
well,
have to do
if we want to know how many moles of marshmallows, let's compare that to 11.37 moles of s'mores we know we're going to make. I told you there's multiple ways to do this. Well, that's based on the equation too. Still, 1 mole of marshmallow, according to my recipe, is going to be used for every 1 mole of s'mores we make, right? If you set this up, what do you get? 11.37 moles of marshmallows. What?
So we already knew that, didn't we?
Well, no, we never actually did the conversion here. Okay? Now, because if I ask you to do it for graham crackers, are we going to need 11.37 graham crackers to use this up? No, because it takes 2 graham crackers for every s'more, right? So we'll have to set up that proportion for graham crackers to figure out of the, how many graham crackers do we actually have? Of the 96 moles of graham crackers, how many are we actually going to use? Well, if we can make 11.37 moles of marshmallows and it takes 2 moles of graham crackers per 1 mole of marshmallow, we're going to need twice this number of moles of, we're going to need 22.7 moles of graham crackers. So then we could say, well, if we have 96 and we're only going to use 22, how many are left over? Whatever the difference is. I'll do that in a second, though. This is the moles of marshmallows used. This is how many we're actually going to use to get rid of all that chocolate.
So the next question says moles of chocolate bars, and we would typically use the bag of marshmallows.
So hold on. Let's just think about what we're doing. We're trying to say how much leftover marshmallows will we have. What we just calculated is how many moles of marshmallows we're actually going to use. We have to compare that to how many moles of marshmallows we have. 39.58 moles of marshmallows is how many we have. 11.37 moles of marshmallows is how many we're going to use. The difference is how much is going to be left over. What's the number? 74.06. That's impossible. That's bigger than the numbers.
28.21.
28.21. That makes sense.
Yup.
Yeah.
So when we're done here, this bag of 40 marshmallows should have about 28 left in it when we're done and we're all out of chocolate, right? That's a lot. It's excess. That's why I'm upset that I didn't tell the person who bought all these to buy more chocolate.
Who was the
Okay,
person who
you had
bought
so
them?
many days, why did you just buy more chocolate?
You yell at us for having 4 days of
I don't know that I'm
nothing.
going to give you any s'mores if I got to do all the work for you.
You're choosing
Is
it.
anything that I did right here all that difficult?
No.
No.
I think it's just hard for us.
It has so
It's hard
many
to-
different
for us to
meanings,
comprehend.
and there's so many like
Okay.
ratios and
Yeah, it's hard for us to understand what ratios and what needs to be on top, on bottom to cancel out to find what we need to know. I
Well,
think that's a little difficult for
I think
us
it's
to
just-
What I always do when I set up a proportion is I say, okay, what am I trying to find and what do I know? That's my proportion on one side. What I'm trying to calculate and what I know I have is a proportion here, okay? And then I look at the units. I say, well, okay, if I'm trying to find the moles of marshmallows and I know the moles of chocolate, I need another ratio that I know is true of the ratio of moles of marshmallows and the moles of chocolate. only way we can get a known ratio of marshmallows to chocolate is from the balanced equation, okay? Now, I think some of you are having that problem because you don't like to read. You see a big paragraph before a calculation, you say, oh, that's so much work, I have to read it, I have to understand it. There's a reason I wrote that. It's to help you figure out what ratios you need. Reread the paragraphs. With the exception of a few calculations here, the leftover marshmallows, I told you how to set everything up, okay? But if you actually pay attention to how these things are done and you're not just writing answers without any work, this should be easy. Okay, but you have to think.
Did you get that shirt from
Flat side on the
H&M?
top and then the pointed side on
That's how it works. It has to be like that.
I thought both flat sides
No.
were supposed to be.
No, that's a different type of question.
Those bow ties.
Actually, no. Every bow tie is going to have a folded end on one side and a flap end on the other side. And underneath that, a flap end and a folded end. I've been wearing bow ties for like 4 years, so I mean, I know you're the bow
No,
tie expert, but
Well, I'm just like so like.
Wait, do you just
I know.
I'm more mind blown about this than like this whole like all of this is like nothing like. That just
do you just clip that bow tie on, or is it like a?
Is it like a clip on or do you have to tie it?
No.
Can you show us? Wait, can you show us really quick? how
No
you
way,
tie
I've
a
never
bow
seen a
tie,
tied
please?
bow tie before.
Please, balls.
Put this on the YouTube.
Oh,
Yeah.
you tried that? Oh my god, this is so.
This is more
Oh my
practical
gosh.
than all the mold stuff.
Yes.
So cute.
This is so.
Something we're actually gonna use in our lives.
you're going to be wearing a lot of bow ties?
Yes.
Well, you know, maybe like, maybe.
Tuck it in there,
Oh
pull
my
it
gosh.
through, give it a little yank,
This is so
Straight.
cool.
really yank.
See, right now to me this is magic, but once you
Whoa.
Wait, who taught you that?
When Mr. Boyd, did you get that information?
Bravo! The internet taught me. And then practice. Practice!
Your
You
dad.
think I could do it without a mirror the first time I did it?
Yeah.
No!
You're bold.
I had to practice it over and over and over.
So you got it right.
So
And
we're
even
gonna
with all the
practice
practice,
this.
sometimes I make a
This
mistake.
lab was the first time we've ever seen this.
Right, which is
So-
why,
So this is
Which
why I
is
chose
why-
the mirror.
which is why I gave you 4 periods to do it. Which is why every time you came up, I helped you to figure out the answer. I didn't give you the answer. Like when Dashiam came in, actually I did something wrong when he came in with a tie. I tied it for him. That was bad. I should have taught him how to tie it. Give a man a fish,
He'll eat for a
You
day.
he'll eat for a day.
Teach
Teach a man to fish, he'll eat for a lifetime. Tie a man's tie, he has to tie for a day.
Oh my
Teach a
God.
man to tie a tie, he'll tie his ties for a lifetime.
Actually,
Question.
Did you get that shirt from H&M?
No, banana republic. Okay,
Yeah, it is.
Okay, so guys, the things we have to be able to do is to take a given amount of something and convert it to an amount of something else. That's what I'm asking you to do in these. This is what I'm going to ask you to do in the chemical reaction. Given an amount of one thing, how much of something else either are we going to make or are we going to use? Right? But the way we do it is all the same. In this method, we got to get to moles first. So we set up the proportions to get us to moles. Once we know how many moles, then we can use the recipe or the balanced equation to convert to something else. But I can't convert to something else unless I'm in moles. Okay? That's one way of doing these calculations. There is another way. Instead of setting up all these mole ratios,
We could just use mold.
we can use mass ratios.
What?
Here's how we're going to do it.
Oh my gosh.
I'm going to take my balanced equation.
It's gonna be like in different units.
I'm going to have to do all the same things I did before. I'm going to have to use all the same numbers, but it's going to look a little bit different. And for some of you, you're going to like the way this looks. So I'm teaching you 2 different methods. Whatever way makes more sense to you, use it. But whatever method you do, you have to do it consistently. Okay? So here's what I'm going to do. I'm going to say, okay, with this recipe, what total mass of things am I actually using? So in other words, we know we're going to use 2 of these graham crackers, right? There's 4 total atoms in there, right? But we're going to use 2 of these things. What do 2 graham crackers weigh? Each graham cracker weighs 3.75, right? Each individual little gram, right? But we're going to use a total of 4 of them in our recipe, right? The 2 times 2. So what is the 4 total graham crackers we're going to use weigh? What?
7.5.
No, 15 point something.
7.5 plus 7.5.
3.75 times 4.
Yes,
That's 15.
Oh, it's exactly 15. Oh yeah. Just 0.75 times 2 is
2.76.
1.5. 1.5 times 2 is 3. Okay. So it takes 15 grams of graham crackers to make our s'more, right?
Yes.
What total mass of marshmallows does it take?
7.1.
7.15, because there's only
1.
1 marshmallow in there, right? The chocolate bars. What total mass of chocolate bars does it require? 3.22 is the mass of 1 little
Times
piece,
8,
but I'm
right?
using
12
8, right?
25.76.
25.76.
Now, if those masses of things are used, what mass of s'more will we make?
47.91.
It better be equal to the molar mass we found before, right? But if you add all these up, it should make 47.91, and I don't know why I wrote before as a 7. Okay. Now, are the left and the right sides equal?
Yes.
If I add 7.15 plus 15 plus 25, does it give me 47.91?
Yes.
It better because of the law of conservation of mass, right? Okay, so what I've done is I've taken my recipe and converted it from a molar basis to a gram basis. I've said for every 7.15 grams of marshmallows, I get 47.91 grams of s'mores.
Yes.
Now, if I want to get this number in black, here's what I can do. 283 grams of marshmallows. Well, we want to know the grams of s'mores, so actually I'm going to put it on top. X grams of s'mores per 283 grams of marshmallows, that's proportional to what?
47.91.
The recipe says for every 47.91 grams of marshmallows, we have to put in 7.15 grams of marshmallows. Right? That's the proportion. Why? Because when we added up what all this total stuff weighs, if you're to go into the lab and add up what all the mass of the graham crackers in a s'more weighs, and what all the mass of chocolate in a s'mores weighs, and what the total mass of the s'more weighs, we're going to be able to get masses of each of the ingredients and the mass of the products. That ratio is the same, right? If I take 2 s'mores and add them up, I'm going to get twice this number, twice this number, twice this number, and twice this number, right? But the proportion is still going to be the same. Even if I double this and double this, it's still the same proportion, right? So solve this. Mia, you got it? Good job. Give everybody else like 20 seconds.
Number 18 times.
Oh, wait, that's what I got. But I also got a different number because I didn't know which way.
I hope the heck we're getting this number down here.
Yep.
Oh yeah, I got that.
Yes! 1,896.27 grams. It's the same answer. We're just doing it in a slightly different way. Some people say it's easier.
What's this always?
Well, here's a problem. Problem is if anybody asks you about moles, we never calculated moles. We don't actually know how many s'mores we can make, do we?
Never do.
In all the other ways, when we did all these, we know how many moles of graham crackers we are, we know how many moles of s'mores we can make, and things like that, right?
No.
here we sort of bypass this process of knowing anything about how many moles we've actually made.
So if
That's a problem if somebody asks you how many actual s'mores you're gonna, you go to UPS and you're like, here are my 1,900 grams of s'mores. And they say, how many s'mores is that? I don't know. Never calculated it.
Calculate
Well,
with the
it's
moles.
sort of less than 2 grams in the box.
Now, we could, since we know the molar mass of a s'more, we could set up the ratio of the grams in 1 mole of s'mores and make it proportional to this many grams and solve for the number of moles of s'mores, right? We could do that. If you understand how to convert to moles, which you are responsible for knowing how to do, okay? But if you're just interested in grams, this is actually the easier way to do it. Okay? The other things we can do with this. I mean, we could get any of these numbers. Again, just setting up these mass proportions. Now, in the other way, we figured out how many moles of marshmallows we would have left over, right? We actually can't do that with this method directly. But we can figure out the mass of marshmallows left over. What mass of marshmallows is this actually left over? Each marshmallow weighs 7.15, 28.21 would be what mass?
$201.
201, 28.21 times 7.14 is 201.
201.705.
Okay. So 201 grams of marshmallows left over. Okay? We can actually get that using these ratios here. But we have to know what the limiting ingredient is. We already know that, so I'm going to save us some time. We know the limiting